Okay, so go ahead and pause if you haven't read through the word problem. We're supposed to make a tank that's square in the base. It's rectangular. Here, let me draw it like this, actually. Okay, square in the base, rectangular. So that means the height could be more than the side lengths of the base. The dotted lines mean it's behind these sides. Oh, that's not very pretty, but I hope you get the idea. Okay, square base. So we'll call this x, and that means this side length is x. We don't know what this height is, so we'll call that y. That's all they tell us, and that they tell us something about its volume. We're supposed to find the dimensions to make it weigh as little as possible. So the material is this stuff on the side, right? This side panel, the back side panel over here, and the other back side panel. And it's open top, so we need to have an area for this thing down here. So you want to minimize the surface area. That's the big idea for this problem. Okay, so A for surface area. I want to create an equation for the surface area, and then I want to minimize that. That way I'm minimizing the amount of material I need for the job. Okay, so the area of the bottom down here, that's a square base, so that's x times x makes x squared. Okay, and then each of these four sides are the same. It's x across and y up, so that's x times y, that's x times y, that's x times y, and that's x times y, so there's four of those. Okay, and we could take a derivative, set it equal to 0 if we had just one variable. There's two variables though, so that's why we need some more information. That's why they told us the volume is 500 cubic feet. The volume of this thing is the area of the base, which is x, times the height of this thing, times y. So that's the volume, but they told us it's 500 for v, so we can plug that in. So this is an equation that could be easily solved for y. X is a little more complicated. And you could plug what y is into this equation so that we just have one letter. So I'm going to divide that x squared from both sides. So that's what y is. So the area is x squared plus 4x times 500 over x squared. Okay, so the x here and one of the x's down here can cancel. And 4 times 5 is 4 times 500 is 2,000. Okay, and that's our area equation, right? And now we can take a derivative, set it equal to 0, and that finds critical points, which are potential maxes and mins. So the derivative of the area with respect to x, this one, the first one's just the power rule, and the second was actually the power rule. This is 2,000 x to the negative first, right? So the negative 1 comes down and multiplies, and then it gets reduced by 1. So that's 2,000 x squared, x to the negative second. Or an easier way of writing that is x squared. Okay, and just to show you what I did off to the side, this is the same expression. I haven't taken a derivative, right? If the x is on bottom, that's x to the negative first. So when I took a derivative, the negative 1 came down, and then it got reduced by 1. But instead of having x squared, negative x squared, I can make it positive by kicking it into the bottom. So that's how I came up with this term with the negative sign. Okay. So that's our derivative. We set it equal to 0, and then we solve for potential maxes or mins, the critical points. And remember, critical points are where the derivative equals 0 or where the derivative fails to exist. So if you plug in x equals 0 into this function, you're dividing something by 0. So that's a critical point. Okay? But if x is 0, then this has no area for the base, right? That doesn't make any sense realistically. You can't have a 0 by 0 volume thing, 0 by 0 thing and still have a volume. So one of the critical points is x equals 0. We ruled it out for real world reasons. We want to multiply both sides by x squared here. So x squared times 0 makes 0. X squared times 2x makes 2x to the third. And then x squared, making sure I did this right, x squared times all this makes 2,000. So to solve that equation, add 2,000 to both sides. Don't don't get rid of the cubed yet. Divide that 2 from both sides. And then use a cube root to both sides, right? In other words, a 1/3 power to both sides, because a 1/3 power on top of an x to the third power, the powers multiply to make x to the first. So this is our answer, 1,000 to the 1/3 power. And if you think about that, that's 10. Because a 1/3 power means something that can multiply by itself 3 times to equal 1,000. So that's 10. So the square base is 10 by 10. And then to figure out what the y value is, you can just plug 10 into any of these equations that have y in them. So this one, or this one, or this one with volume plugged in. So I'm going to plug 10 in here. 10 squared is 100. 500 divided by 100 makes 5. So y is 5. So it's a 10 by 10 by 5 thing. Those are the dimensions we need to use.